You would be right. They were used extensively in movies and entertainment. But when Nikola Tesla invented this, that was the last thing on his mind. Actually, he probably didn't even think of that at all. What he wanted to do was to actually create wireless transmission of electricity. The way that works is, so as arcs fly through the air, creates an electromagnetic field that can actually pass through the air like a radio wave and could actually be received by electronic devices and they'd be powered. Now, I'm going to prove this to you. We have a group of light bulbs, or actually fluorescent light bulbs. They're on the other side of where I'm at. The other window, in that plastic box. There's a little copper wire coming out around a spool, and it's acting like an antenna to receive the electricity. And as the arcs fly through the air, the light bulbs will light up as the electricity that is wirelessly transmitted. So check this out. I'm going to be discharging the arcs. So look at the plastic box. As you can see, they light up. So, gee, well then how come I don't go over the the south side here, over a view of Los Angeles and see Tesla coils blasting away? Well, there's a few problems with the Tesla coil for using for transmitting electricity. The field weakens as you move away from the coil, which means you would have to have very large ones going 24 hours a day, about a block apart, a few blocks apart, have Tesla coils. That would be very noisy. Now this produces something called ozone. Those arcs, they actually produce ozone. Now ozone is really good for the upper atmosphere. What it does is it blocks the ultraviolet rays, so it's really important. However, down by the surface, it produces something called smog. So we wouldn't want to be producing all that ozone, and the noise would be tremendous. And let's face it, the power companies aren't in the mood to transmit electricity through the air and not be able to charge it to use. So that didn't really work out. But when Nikola Tesla came to this country, Edison was using direct current. Same thing he used in batteries. It's not very efficient. He had to have these power stations with these big, powerful dynamos churning away and pushing the current through the transmission lines. Every few 3-4 blocks, you'd have to have a new one. With alternating current, you don't need that. It goes through the transmission lines a lot more efficiently, and is now used throughout the world. Not only that, he also invented the AC motor. So when the Industrial Revolution was going on, that came in quite handy. So when you open up your refrigerator, push your vacuum cleaner across the floor, thank Nikola Tesla, or if you're lucky enough to have one of those new cars that have a AC motor in it, that's also his idea. So I guess it's appropriate to call that car company Tesla. So let me give it another demonstration. I'll explain how it works. This is a device that doesn't actually create power. It's taking normal voltage out of the wall, which is about 220 volts at 60 cycles, alternating current. And what it does is it steps up the frequency and voltage. So it goes from 220 volts to about 500,000 volts. And then the frequency goes from 60 to a little under 100,000 cycles. What that really means is it goes from a form of electricity that flows through the wires efficiently to one that can flow through the air. And also, you're probably wondering why this cage is here. It's called a Faraday cage, and it's really not to prevent the arcs from flying out and hitting us. What we're trying to do is to prevent that electromagnetic field from coming out. While it's safe for us, for all this really great equipment you're all holding here, it's not good for that. Those all have little computers inside, and electromagnetic fields aren't good for those. They would actually disrupt the show and do all kinds of stuff. So we put the Faraday cage here, allow you to get up close to it, or if even somebody had a pacemaker, it would be safe for them to get up here and see this without having any kind of electronic devices affected. All of you have one at home. Your Faraday cage is surrounding a microwave oven. Otherwise, the microwave radiation will just leak out all over the place. It contains it inside the microwave oven. You can see it in the door where we have that little view inside. There's that grid that's there. I've always wondered, what is that grid there for? Well, that prevents the microwave radiation from getting out. Okay, what I'd like to do now is actually give you a chance to get a photo op of this incredible device. What I'm going to do is let you set your cameras up and count down to 3 and let you take a really good picture. And afterwards, if you'd like, come up. If you have any questions, I'll try and answer.
今カメラシャッターチャンス。
Okay, on the count of 3.
はい。
1, 2, 3.
3。
All right, that concludes this demonstration. If you have any questions, thank you.